You're given a whole number, and your job is to find the two digits inside it that multiply together to give the biggest possible product. Keep in mind, if a digit shows up more than once in the number, you're allowed to use it twice when picking your pair. So you just want to return that highest product you can make from any two digits in the number. Intermediate level, change one digit in this number and the correct answer swings by 60. Most people multiply the wrong two digits and never notice. By the end, you'll spot the two biggest values trick instantly. This top two values trick shows up in leaderboard systems, bid engines, anywhere you need the best two numbers without sorting everything. It's a tiny problem, but the underlying skill is one you reuse constantly. We get a number like 124, split it into digits 1, 2, 4, and try every pair. 1 times 2 is 2, 1 times 4 is 4, 2 times 4 is 8, so 8 wins. Think of it like tearing a number into individual paper digits, laying them in a tray, then walking down the tray, checking each one. That's a string, a list, and a loop. That's the whole toolbox for this one. Picture a leaderboard with only two spots, champion and runner-up. As each new digit walks in, it either beats the champion, beats the runner-up, or doesn't place at all. Walk through the digits once, keep those two spots updated, and you never have to compare every pair. The obvious move is to just try every pair of digits with two nested loops and keep the best product. This works fine here since n has at most 10 digits. But it's doing way more comparisons than it needs to, and that habit gets expensive on bigger inputs. We turn the number into a string so we can look at it character by character, then convert each character straight back into an integer. This gives us a clean list of digits to scan. We start both trackers at 0, then for every digit we ask, is this bigger than my current biggest? If yes, the old biggest slides down into second place, and this digit takes over first. Otherwise, we just check if it beats the second spot. Once we've scanned every digit, max 1 and max 2 hold the two biggest values we saw, so we just multiply them. In short, one pass, two trackers, one multiplication at the end. Quick pause before I show you. N is 22, so the digits are 2 and 2. What do max 1 and max 2 end up holding? And what's the final product? The first two becomes max 1. The second two isn't strictly bigger than max 1, but it is bigger than max 2, which is still 0, so it slides into max 2. That's why repeated digits still work, and that's the whole reason this handles the 22 case correctly. Clean. The tracker approach scans the digits once and uses only two extra variables, so it's linear time and constant space. Brute force checks every pair, so it's quadratic. Since n only ever has up to 10 digits, both run instantly here. But the tracker habit is the one worth keeping. Honestly, my opinion is brute force is overrated for anything called pick the top two. People reach for nested loops out of habit when one pass always does it cleaner. I made that exact mistake early on, brute forcing a top two problem before realizing one loop was enough. If both digits are the same, like 11, max 2 still fills in correctly and gives us 1. If there's a 0 in there, like 10, the product correctly comes out to 0. The loop doesn't care how many digits there are, it just scans once regardless of size. So remember that, 22 case that could have tripped us up. Now you see why keeping max 2 starting at 0 and updating it on ties handles it perfectly. One pass, two trackers, done. This top two tracker pattern is your foundation for top K problems everywhere. And tomorrow this same trick helps crack a much harder version with 3 numbers instead of 2. This took real effort to explain. Takes none to hit like and follow.